This is going to be a video describing how to solve equations using roots, various types of roots, not just square roots, but maybe third roots, fourth roots, or any kind of a root. In order to understand roots, however, we first need to remember how to use them. So one way we see roots, again, are as rational exponents. If you see something like a 16 to the negative 1/4, remember that a negative exponent means that we would be basically taking the reciprocal of, or finding 16 to the 1/4 in the denominator of a larger fraction. However, a fractional exponent is a root. So a 1/4 exponent up here is a fourth root of 16. Remember, that's still on the bottom of our fraction. And if you carefully check that out, fourth root of 16 is equal to 2, or if you remember, 2 to the fourth would have been 16. And so your answer is actually a 1/2. Now, what do you do when that radical expression, or that fourth root of 24, doesn't come out cleanly? Fourth root of 16 was 2, but the fourth root of 24, unfortunately, 24 is not a nice fourth power. So you can type it directly in your calculator like this, or you could say 24 to the 3/4, again, 3 being the exponent, 4 being the index, or the denominator of your exponent. You can type it into your calculator either one of those two ways. So if we start off with parentheses, the fourth root of 24, and then make sure to take that whole expression raised to the third, we should end up with the same answer that we get from 24 raised to the 3 divided by 4, or 3/4. And notice both times we get 10.843 rounded accurate to 3 decimal places. So 10.843 approximately. And note that an approximate answer was okay for that problem. Now, the idea of those roots can help us when it comes to solving equations. Again, first thing you always want to think when you're solving an equation is, if I only have a single variable, note nowhere else in either one of these two equations do you see any variables other than that single x that you have, what are the easiest ways to peel off the layers? So there are three things happening in this equation on here on the left. We've got x cubed, then it would be followed by multiplying by 5, then adding 10. Remember, that would be the order as far as PEMDAS goes, or your order of operations. When we're solving equations, though, we're going to go backwards. So the first thing I want to get rid of is that 10. So 5x to the third equals 951. Divide that by 5. Next easiest thing to take away. So x to the third equals 951 over 5, whatever that may be. And finally, in order to get rid of a third power, we want to take a third root. So if we can go to our calculator again and find the third root, so control root, third root of 951 divided by 5, we get 5.751, and that would be our answer. 5.751 approximately answer to our problem. So over here on the right, first thing to do then would be divide by 2. 35 divided by 2 is 17.5. As long as you're not rounding, that's perfectly fine to use a decimal. Then we're going to take our fourth power, getting rid of it by using a fourth root. You also could have taken this to the 1/4 exponent, or that's the same thing as a fourth root. So the fourth root of x to the fourth becomes x, and the fourth root of 17.5, again, fourth root of 17.5 is 2.045. So we'll call this 2.045. Now you also have to be careful, because remember, an even power means that negatives would also have turned into a positive 17.5 times 2 is 35. So when we take the fourth root on both sides of an equation, we have to remember to say plus or minus. Remember, we didn't do that over here on the left because it was a third root. Odd roots, you don't say plus or minus. If you wanted a negative answer, the number underneath the radical would have needed to be negative to begin with. Last thing for you is just an example where you may see something like this. Again, any equation that involves a power means we could involve some roots. So a mechanic is working with a ball bearing that has a volume of 720 cubic centimeters. Find the radius of the ball bearing given the formula for the volume of a sphere. So if we know that our volume is 720, we can plug that in for the volume, and we just need to figure out what R is. So the first thing I would probably do is go ahead and multiply by 3/4, same thing as dividing away your 4/3. And as long as you're at it, since pi is on the top of the fraction essentially, you would want to divide away the pi. You could actually put that pi on the bottom of the fraction as well. That will cause the 3 on the top cancels the 3 on the bottom, 4 cancels the 4, and the pi divided away, all those things will disappear as long as we also multiply by pi, again in the denominator, so make sure we note that correctly. If we're making that fraction, put pi in the denominator over here. So r to the third then would be approximately equal to 720 times 3, but divided by the quantity 4 pi. And we should end up with about 171.887. But then remember we need to take our cubed root to cancel our third power. Again, same thing as saying 1/3 exponent. So if you really wanted to, we could actually type in 171.887 to the 1/3 power. You could type it either way, third root or 1/3 power, but on your calculator, I can then say, well, let's copy that answer then, and let's go ahead and take it to the 1/3. And 5.560, again, if we're in cubic centimeters for the volume, this is in centimeters for the radius, and there is your answer. Hope that helps you work with roots and solve equations. Have a great day.